Hello, everybody, and a good day to you wherever you are in the world. It is with great joy that I welcome you to my presentation at RoboCon 2024. I'm very excited and honored to be here. I hope that you enjoy this presentation as much as I enjoy preparing it. My name is Thales Paiva. I work as a process analyst, and I'm currently a master's candidate in software engineering. You can find me on X/Twitter or on LinkedIn, and I will be more than happy to connect with you and discuss further ideas related to process automation and test automation. Also, any feedback related to today's presentation is very much appreciated. Receiving honest and constructive feedback is always good, even if it can be harsh sometimes. I appreciate it nonetheless. Which brings us to the topic of our presentation today, the automated generation of acceptance tests of process-aware information systems, aiming at increasing test coverage through model-based testing. But what is a PAIS? Just to level the ground, a very quick explanation of what is a PAIS. Process-aware information systems are software systems that support the execution and management of business processes. It typically consists of three main components. First, a modeler in which the process model is designed, and a set of rules and configurations can be declared. In our case, we are using the Camunda Modeler, an open-source process modeling tool which implements and reinforces the BPMN 2.0 standard. We'll dive further into the nitty-gritty of BPMN later, but for now it suffices to say that it is a standardized workflow representation. Second, a process engine capable of interpreting the process model and controlling the flows and outcomes of each interaction. In our case, we're using the Camunda 7 engine, a Java-based open-source process engine with rich documentation and a thriving community of users. Third, a monitoring and analysis tool responsible for capturing the human interactions with the process engine, as well as displaying the status and the data contained in the processes. For this third component, we are using the Agile Key Process Automation Platform, an open-source project devoted to facilitate process and workflow automation initiatives based on code generation techniques. And this is a continuous and iterative process in which the analysis of the previously executed processes provide valuable information for evolving the process model, improving its efficiency over time, hand in hand with the continuous improvement paradigm. The main motivation for the present work is the fact that testing a PAIS is complex by its nature. Although that can be said basically about any type of system, given that software testing is a complex activity per se, a PAIS has some specific characteristics that act as catalyzers in this aspect. They are firstly the multiplicity of flows within each process model and require that all these flows must be mapped and tested to guarantee test coverage of a version of a process model. Given that one of the strengths of a PAIS is that it enables and encourages the citizen developer to propose changes to the process model and its flows, maintaining test coverage is a big challenge. Keeping track of changes in versions of a given process model and correlating it to the test suite, it's imperative to achieve the aforementioned test coverage. Secondly, within each of the possible flows, the forms, which are the human interaction points within the process, can have different behaviors depending on rules. Therefore, the presence or not and the behavior of each field in each form should be tested, taking into account such rules. Here again, given the ease in proposing changes in the process by the citizen developer, maintaining test coverage is even harder. Lastly, there could be many other functionalities in the system that aren't directly related to a specific flow or process model, but are part of the system nonetheless and should be equally tested. Given its repetitiveness, with minor changes between the test cases and the amount of test cases derived from each process model, testing a PAIS can lead to high-maintenance test suites with a labor-intensive and error-prone test execution strategy. And let's be fair, there's absolutely no joy in tedious, numbing, repetitive work. Imagine if there was a way to automate this. How convenient it would be if there was technology, a tool, or a framework to help us to automate such test executions. Well, we all know where this is going, right? I quickly mentioned that one of the characteristics of a PAIS is that it has an underlying process model, which in our case is the Business Process Model Notation 2.0, or BPMN for short, a standard maintained by the Object Management Group, the same group responsible for maintaining the UML standard, for example. Given the fact that a PAIS has an explicit model as a key artifact, a model-driven testing approach could be an interesting strategy to automate such tests. This assumption is, in fact, backed by a set of scientific articles and gray literature. So, from a process model, it would be possible to derive the test cases. Looking at this present process, we can see that, for example, there is a unique flow highlighted in green given by the decision made after the gateway element entitled type to take the lower path. This could very well be our test case 1, for example. There's another unique flow highlighted in yellow taking the middle path, which will be our test case 2. However, if you happen to take the upper path highlighted in blue, there are a couple of different possible paths within that path, which must be considered to guarantee test coverage. As still doable, the tester only needs to be extra careful interpreting the process model to derive all test cases possible and implement the automated execution scripts for each one. So if you consider that done and you automate the execution, then, well, no more frustrated tester executing repetitive tests over and over, right? You automate the test cases associated with each flow once, and it's done. Happy ending. Well, not so fast. So consider this. You no longer need to spare a tester to execute the test, for execution is automated. And it has one big upside. An automated regression test strategy become a possibility, which is another benefit pointed out in the literature. But it's not all roses. You still have your good and old regularly overloaded tester or QA engineer creating and maintaining a whole lot of automation scripts associated with each process test suite. At least now the tester is only writing and maintaining automation scripts, not executing boring repetitive tasks, although it's a large set of scripts. But it's still a win, right? Well, again, not so fast. That's only possible if the process models don't keep on changing. Oh, but they do. Like, how dare you, business? Jokes aside, here it's important to remember that one of the key aspects of a PAIS is the ease in proposing and implementing changes in the workflow. Therefore, it is expected and normal to assume that a citizen developer on the business side will change the process on a regular basis in the pursuit of continuous improvement. That alone is enough to break the regression test strategy while increasing the work of the already overloaded tester or QA engineer. Poor thing. So given the changes in the process model could and probably would break the previously written test suite automation scripts, how can we automate testing of a PAIS? How can we make this castle of cards more stable and reliable? What if we could automate the generation of the previously mentioned test suite based on the process model? In this way, we could have both automated, the generation of the test suite and the execution of the test cases in it. What's important here is that given the automation scripts within the test suite are generated on the fly, based on the process model, if the process model is changed by the business or by the citizen developer, a new set of automation scripts can be generated with very little effort by the tester or QA engineer. In this way, the test suite can be automatically updated to reflect the changes in the new version of the process model, enabling again the possibility of implementing a regression testing strategy. The key takeaway here is, given how frequently process models might change and evolve, the automated generation of the test scripts is as important, if not more important, than the automated execution of the test cases. Our implementation achieves these through a Python script that manipulates the BPMN's underlying XML along with some other reference architecture files from the target system and generates the robot framework automation scripts. We are currently using Selenium, but we are considering migrating to Playwright. And we utilize the fake library for mocking the test case data. Shout out to Guy Kisel. I don't know how to pronounce his name, but I would like to give him a shout out for the wonderful work. It is important to state that having a keyword-driven RPA is key for our solution. So with that said, let's get our hands dirty and see some of the details of the implementation. It's time. Demo time. So here is our so-called Python script. It begins with a set of configurations and functions, and it manipulates the BPMN to gather a set of important information. And it also manipulates the reference architecture files, which in our case is a set of JSONs, which are directly related to how So for example, here we can see that the view and the TypeScript of each of this user interfaces, like the files related to how the user interfaces behave, they are all tied together. So we are trying to manipulate that. So that's important to have in mind that depending on your target system, you have to know where to find such informations to manipulate it. But here we are manipulating those, and we from those information we get a set of lists and dictionaries with all this information, and we use that to generate our test and our resource files, robot files, which look a little bit like this. So let's give a quick example. Here is our platform, and let's deploy a process which is this version 1 of this process. So we deployed it, and this is our process. So it's like this, and we can see it here. This is the process. It's just a small process, begins one way or another, and then it ends pretty much. It can log something to console, but it's pretty much this. This is the human interaction points. So with this, what we can do is feed it to the Python script and generate our robot files. So let's do it, and lo and behold, here is our test and our resources. So in the test, we have a bunch of information about where should we interact, how should we interact with each of the user interfaces, and the implementation or such keywords. So it's aware that in this user task, it's supposed to have these fields. In this other user task, it's supposed to have these fields. So it's aware of that, and the locators and everything comes from there. So let's see it working right now. So I'm going to run a test, and it's going to execute 10 process instances. We can do it parallelized if you wanted, but I'm just trying to see it. And we can go headless, which is much faster. And I have a bunch of sleep and wait for us to be able to see things happening. But this could be much faster. And even with these, like not going headless and not having and still having the sleeps, we average like 4 or 5 seconds per process execution. And a human tester usually would take around 30, 40, 50 seconds to execute each process instance. It has to go through each field and find where things are. So that's an order of magnitude. And you're giving way more tests. You're testing way more extensively, in a sense. So yeah, it's executing, and then we can follow what's going on in the test. But yeah, that's pretty much it. But let's suppose that the business sides decide that now it wants to, depending on the gravity of what happened in the process, it analyzes the complaint, and if say, oh, this is serious stuff, this is grave, I should escalate it. I should ask my supervisor to take a look. I should ask my manager to take a look. So if that's the case, it wants to implement this bit of decision in the process. So it creates a user task, it generates the rules over here, and then for the business side, that's it. That's what he wants to do, and that's what he will do. So if we think about it, the business side would just come over here, deploy a new process definition for that process, a new version of that process. And from the business side perspective, that's it. It's implemented. So according to him, like things are working and that's it. But if you want to test it in an automated way, this is not going well. It's not going to go well because your robot script is not aware of this new user task. It's just not aware. And we can actually see that happening if we force it to try to execute tests that will go bad. So let's just ask it to run again a set of tests and see what's going to happen. Just a second. Okay, here we go. So now it's going, and okay, a suggestion. It has nothing to do with that flow. Another suggestion has nothing to do with that flow. You can actually, I'm going to show after, like you can go on a linear base. You can tell it like exactly which way you want it to go. But this is like blind. This is like simulating a bunch of users doing whatever they want to do. So that's the approach we're going, because we want to test it like more extensively. And funny enough, it's not getting a single complaint. Oh, finally a complaint. So it's going to analyze, going to give it a gravity, and it's going to break because it doesn't know what to do with the review escalation user task. It got an error, unexpected test found, and it broke. So for the tester, if you're doing a regression testing, you're going to see that something is wrong with the platform, with your application. So you're going to go, oh, this is the process model. Let me check it. Oh, the business side did something. Or you could be on par, but if you're not, you would see afterwards, oh, the business side did something. So I have to correct it. What you're going to do is you're going to prepare a new set of test cases. What you're going to do is you're going to run it again. So now with this new process model, and you're going to run your Python script again and generate new resources and test robot files. And lo and behold, in the new test robot file, now you can see it gets the task review escalation. Now it's aware of it. And this is from the previous execution, but now it is aware. So now if we want to try it again, and let's again ask it to go, so we can actually go straight to the review escalation. We can try and run a set of tests again, and now it's not going to break. And in fact, it's going to begin this test by going through the previous task that broke the other time, and it's going to go well this time because it's going to find it and it's going to be able to deal with it. So let's see it happening. It's creating a new form, but now it gets the review escalation, and now it's done. It was able to deal with it, even though it's from the previous execution. Now it was able to do it, and another one, it's going to go again and it's going to review escalation again, and now it's not a problem anymore. So I updated the process model. I generated a set of new tests and robot, and now it's working properly. So there is a direct relation with the process model and the automation scripts that are being generated by it. So with that said, I want to finish the presentation with a set of takeaways. And so automating the generation of test cases is as important as automating its execution. Helping the tester focus its attention on more meaningful work is very important. And now with that, you can implement a regression testing strategy, because now it is a possibility, because you can always be going back and remaking it. And with that said, I would like to thank you very much for your attention. I hope you enjoyed it. And again, I would deeply appreciate any sort of feedback. Please feel free to connect and contact me. If you have any questions, I believe that now it's the time for us to go through some of them. So see you on the other side. Bye.
Awesome. Thank you, Talis, for that. I see you in the green room. We're about to go live. Get your questions in now, and let's do this. Hey, Talis, welcome to RoboCon.
Hello. Can you hear me properly?
Yep.
Yes.
Can hear you. Look, sound great.
Good.
Cool.
Perfect.
All right, let's get into it. First question is, I think you mentioned this in passing. You said you're considering moving from Selenium to Playwright. Why?
basically feedback from some people more knowledgeable than me regarding screening automation and the benefits that could come along with that. But it's basically just listening to people that are way more knowledgeable than me. So we've been considering that, but not implemented that yet. That's like the next step. But that's basically feedback from other people from the community that uh, have great feedback to give always.
Absolutely. So I'm a novice. I'm just curious. I may have missed this. The process graph you had, is that built into Robo Framework, or was that a different software that you use that you then use to automate Robot Framework behind the scenes?
That's actually BPMN. So it's business process model notation. It's BPMN, and you would do that using a modeler, like a desktop modeler or something. Actually, I was using a VS Code extension from Miragon, and they have like a really good way of doing that straight on your VS Code and your IDE. But that's not related to Robot Framework in any way. But it's just like there on VS Code, and you do it all in the same place.
Oh, really cool. So Adam wants to know, are the tests generated locally or remotely on some pipeline? Have you automated also the creation of pull requests when tests are created?
Locally, the test is generated locally. We've been exploring some, because this is part of my master's dissertation.
Oh, cool.
So this is not yet into a production environment, but we are considering it in a production environment. But right now, it's all made locally. It's not integrated in the pipeline yet, but we're moving towards that direction. So if you actually have some sort of expertise or tips you want to give me, you're more than like, I would really appreciate it.
So we're gonna have a dissertation. It'll be about Robot Framework and this whole process when you're done.
Yeah, Robot Framework. It would be like two Robot Framework and Camunda, two great open
So
source
cool.
projects helping in this whole scenery.
That's awesome. All right, Heinz wants to know in the test case. Let me highlight it. So, in the test case TCO3, a waiting time of 3 days is planned for a task. How does the test robot check whether the process is actually continued after 3 days?
It doesn't, not the Robot Framework. That's all managed by the process engine. So the Robot Framework acts on tasks that are available to it. So if it has to wait for 3 days for a task to be available to it, it just wouldn't get it, and it would stay there. What we consider implementing is, what we want to do over here is check if wait times are being respected. So what we consider is, in a future implementation, is we could get those type of timer events, and at the XML change it for example 3 seconds or 30 seconds, and that could be tied to what the robot framework, to what the robot is aware that should wait. 3 days, it's just too much for a simple regression testing before put in production. But we could mimic and change that to reflect a more realistic way of doing it during test. But no, that's the robot framework's not aware of that exactly.
Will you continue with the process flow testing? What is coming next on the roadmap?
Yes, we will, not me, but the whole group of researchers that is associated with we will. Actually, that's I'm going for a PhD now, and we're supposed to dive much deeper into it, because that was just my master's dissertation. We're gonna dive much deeper, and we are considering. I know it's all the hype about AI, LLM. Everybody want to talk about it,
Yeah.
but we were pretty much aware of that even before, because just hard coding every single possibility is just not really scalable. We need some sort of way of matching the semantics of a process with the process model itself. So we're considering something in that direction. But yeah, we will continue, and it's part of our plan to make it more reliable, more robust.
Very cool. You have to come back once you do that with AI. That'd be awesome.
Yes.
How are the test steps generated that check specific data attributes for correct values?
That's actually we can do that because we know what type of data. If I got the answer the question correctly, each type of field has a specific type of data that is expected. Because it's there in the reference architecture files, we can check, oh, this field over here expects integer, expects a number, and expects a date. So what we can do is consider all types of data you want to work with, and then you can do the expected fail. So this is supposed to be a number. Let me try to put letters or a date or something, and it will break. But you're expecting that. But you can work on the complement of not complement, yeah, the complementary part of what that data field is about. That is actually an open issue that we are going next. So how to make each of the user interface tested not only the happy path, but for each user interface and each field in each user interface tested as way more what it should go wrong and expected and have a success still.
Nice. Could this way of test case generation be applied to any kind of BPM model? Could I reuse it in my projects too?
Any kind, it's a difficult way of putting it because we still have some restrictions about which sort of elements we can get. We can get exclusive gateways, we can get parallel gateways, and we can, well, most of the times it works for inclusive gateways, but not any type of, we're having a hard time with event-based sub-processes. So some BPMN models will not work, others will work perfectly. But it's, yeah, not any kind of BPMN. But yeah, you could use it. And I think the repository is open. I don't remember, but it's supposed to be. It's part of my dissertation. My dissertation is a public. It's going to be public. So yeah, it's all going to be public and available to whoever wants to use it. But I just don't remember the repository right now, but it will be.
Cool. Anonymous, have you already checked out RF7 and the new listener API version 3 with the new start _ keywords?
No, I haven't checked RF7 yet. There's still RF6, but I'll take that into consideration.
Awesome. Probably time for one last question. How would you recommend teams get started with model-based testing for business processes? What skills or knowledge do you think are important?
It's about like really, you remember like the Doctor Strange in the Marvel movie,
Oh,
like
yeah.
seeing all the possibilities in the future. You have to look at a process model and really see all of it to actually see if your script is doing a good job or not. So it's about really exercising, maybe like chess. I don't know. Like it's about really exercising a whole lot of movements in the future and making a whole lot of adjustments to whichever model-based strategy you have. But it's about really diving deep and like maybe studying graphs. Graphs is a great way of helping with that. I don't know. It's not an easy subject. It's not an easy way of doing things. But it's really rewarding when you get something right. It's really rewarding to see like how much time you can save by doing model-based testing. I just enjoy it. I love it because you just see like it saves a lot of time when it goes live.
Absolutely. Really
Did it
cool
help?
stuff. Yeah, absolutely. So speaking of helping, which side will you be on in GatherTown? I'm sure people have a lot of questions. Will it be the light side or the dark side?
Oh, the rebels all the way.
Okay.
Light side. Definitely. There's no question there.
Awesome. Sounds good. Thank you so much for this session, Talis, and really appreciate you contributing to RoboCon online. Thank you so much.
Thank you very much. Thank you.
See you next time.
Bye-bye.
Cheers.